in October 2025, millions of, well, perfectly functional lightning-fast computers are going to effectively become digital paperweights.
Yeah, it's quite a deadline.
Right. I mean,
Yeah.
they won't physically break, the screens won't crack, but there's this silent security barrier built directly into the silicon of modern motherboards that is going to permanently lock them out of the future.
Completely cut off.
Exactly. You could have a machine that boots up in 2 seconds, runs your favorite games flawlessly today, but when that deadline hits, it gets completely cut off from critical updates. So today, we are tearing open the invisible anatomy of your PC to find out if your machine is going to survive the great hardware purge or, if it's just destined for the e-waste bin.
And it really is one of the most aggressive architectural shifts we have ever seen in personal computing. I mean, we are moving from a world where software was just a layer sitting on top of the hardware to a world where the operating system and the physical microchips are, well, they're cryptographically fused together.
Fused together. And that is exactly what we are untangling today. So, welcome to the deep dive. We've got our hands on the architecture blueprints today.
The CompTIA A plus certification materials specifically.
Yeah, exactly. Focusing on operating system architectures, Windows editions, and the really hidden mechanics of how these systems actually install onto bare metal. Now, you might be thinking, I'm not an IT guy. Why do I care?
Oh, but you do care.
You definitely care. Because this is the plumbing of your digital life. Whether you're a gamer building a custom rig, a student buying a laptop, or, I don't know, an entrepreneur trying to secure your small business data, you are constantly making choices about operating systems. And if you don't understand the underlying logic,
you're flying blind.
You are flying completely blind. So we're going to decode the alphabet soup of Windows architecture, figure out why certain features are paywalled behind different editions, and ultimately empower you to take total control of the hardware you actually own.
Because if we connect this to the bigger picture, knowing how an operating system interacts with hardware, it isn't just trivia. It dictates the limits of what you can build, what you can protect, and honestly, how vulnerable you are when you connect to the open internet.
So let's start at the absolute physical foundation. Before we can even debate Windows Home versus Pro or untangle international software laws, we have to look at the microscopic math that governs everything.
Right, the Great Divide.
The Great Divide, yes. 32-bit versus 64-bit architecture. Now, if you've ever downloaded a piece of software and been prompted to choose between by86 and by64...
Which happens a lot less these days, but yes.
Right, but you've probably encountered this divide at some point. Now, I know 32-bit is considered legacy technology, but to understand where we are now, we really have to understand the wall we hit back then. Why is a 32-bit system hard-capped at using only 4 gigabytes of RAM?
Well, it comes down to the literal mathematics of memory addressing. Think of the processor like a massive postal sorting facility. And the RAM, the system memory, those are the mailboxes. To put data into a specific mailbox, the processor needs a unique address for it. So in a 32-bit architecture, the processor uses strings of 32 ones and zeros to generate those addresses.
Okay, so it's a finite number of combinations then.
Exactly finite. If you do the math, 2 to the power of 32, it gives you exactly 4,294,967,296 unique addresses.
That is, wow, you know that number off the top of your head.
It's burned into my brain.
Yeah.
But basically, that's about 4 billion bytes, which equals 4 gigabytes. It is a hard mathematical wall. If you have an old 32-bit motherboard and you physically snap 16 gigabytes of RAM into the slots...
Like you just shove it in there?
Right. The processor literally cannot see the extra 12 gigabytes. It just lacks the numerical vocabulary to assign them addresses.
Okay, so imagine a librarian with a card catalog, right? And it only has space for 4 billion index cards. Once those cards are filled out, it doesn't matter if you build a massive annex onto the library to hold like a trillion more books. Yeah. The librarian literally has no ink left to write down where they are.
That is a perfect way to visualize it. The building expands, but the index is totally frozen. And this became a catastrophic bottleneck for the computing industry in the mid-2000s. We had hard drives getting massive, programs getting complex, and video games requiring high-resolution textures. But the active workspace, the RAM, was just suffocating under this 4 gigabyte limit.
Which brings us to 64-bit or by64. The jump in scale here isn't just an upgrade, it's practically science fiction. Going from 2 to the power of 32 to 2 to the power of 64. I mean, the math on that yields a theoretical limit of 16 exabytes of memory.
Which is roughly 16 billion gigabytes?
16 billion gigabytes. You go from a library with 4 billion books to a library that spans the entire galaxy. But here's where I have to pause for a second. Because looking at the actual specs for modern Windows, Microsoft isn't letting anyone near 16 exabytes.
It's not even close.
Right. There are severe artificial caps. Windows 11 Home is capped at 128 gigabytes of RAM. Windows 11 Pro is capped at 2 terabytes. And Enterprise or Workstation tops out at 6 terabytes. If the 64-bit math allows for billions of gigabytes, why on earth is Microsoft building an artificial fence right at the entrance of this boundless prairie?
Well, what's fascinating here is the intersection of software engineering and market economics.
Okay.
From an engineering standpoint, memory management is incredibly complex. The more memory an operating system is allowed to address, the larger the page tables become. And then more CPU cycles are required just to manage the map of the memory itself.
So it actually slows things down if it's too big.
It can, yes. Validating an operating system to run flawlessly and stably with 6 terabytes of RAM, it requires a totally different level of kernel optimization and testing than validating it for just 128 gigabytes.
Okay, I hear you on the testing part, but let's be real here. It's mostly about market segmentation.
Oh, of course. It is absolutely about market segmentation. No home user writing essays or playing a PC game actually needs 2 terabytes of RAM. So Microsoft artificially caps the Home Edition to ensure that, say, the visual effects studios rendering 3D movies.
The research labs running massive fluid dynamic simulations.
Exactly. Those people are forced to purchase the Pro or Workstation editions. They are segmenting the product to extract revenue from the users who genuinely require industrial scale capacity.
It's the classic, charge them if they have the budget for it strategy. But let's look at the transition itself. Moving an entire global industry from 32-bit to 64-bit sounds like an absolute nightmare. Like if you bought a new 64-bit computer back then, would none of your old 32-bit software work?
And that was the massive danger. If Microsoft had forced a hard break, user adoption would have stalled completely. Businesses wouldn't upgrade if it meant losing their custom accounting software. So Microsoft engineered a brilliant compatibility layer called WoW64.
WoW64.
Yes, it stands for Windows 32-bit on Windows 64-bit. It is essentially a subsystem that sits inside the 64-bit environment, and it dynamically translates 32-bit system calls into 64-bit system calls.
So it's an emulator, basically.
Yeah.
It creates a little simulated 32-bit sandbox for the legacy program to run inside, and the program has no idea it's actually running on a 64-bit machine.
Exactly. It intercepts everything. If the old program asks for a memory address, the WoW64 layer grabs a 64-bit address, translates it down, hands it to the program, and basically says, here you go, business as usual.
Wow.
It allowed for a completely seamless transition over 2 decades.
2 decades of hand-holding.
Yeah.
But that era is officially dead now, right?
Yeah.
If you look at a brand new Windows 11 machine today, the 32-bit operating system doesn't even exist. It is 64-bit or nothing.
Yeah, we have finally outgrown the need to support the 32-bit hardware architecture. Modern CPUs, advanced virtualization, and just the massive memory requirements of everyday web browsing have rendered 32-bit completely obsolete.
Okay, so the physical architecture is established. We are all living in a 64-bit world. But now we have to climb up to the software layer and figure out what rules govern our interaction with that hardware. This is the great divide between the consumer and the professional, Windows Home versus Windows Pro.
The big decision.
Right, and we already know Pro unlocks massive RAM limits, but the real divergence is how these operating systems behave on a network.
Right, and this is where we transition from talking about hardware mathematics to organizational management. The core difference between Home and Pro boils down to 2 networking concepts, work groups versus domains.
Okay, let's break that down. A Windows Home machine operates in a work group. It's essentially peer-to-peer.
Yeah, think of a work group like a neighborhood of independent sovereign houses. You might share a physical street, or in this case, a Wi-Fi router. And you might occasionally lend a neighbor a tool, like sharing a network printer.
Sure.
But every house has its own keys. The user accounts, the passwords, the security policies, they're all stored locally on that specific hard drive. If you want to change a user's password, you have to physically sit down at that exact computer to do it.
But a domain, which requires Windows Pro, is a totally different beast.
Oh, yes. A domain is like an apartment complex managed by a really strict landlord. It requires a centralized server running Active Directory. In a domain, your laptop doesn't really hold your user account. When you type in your password, the laptop securely queries the central Active Directory server and asks, hey, is this person allowed in?
meaning the IT administrator has absolute centralized control. They can disable an account on the server, and instantly that user is locked out of every single laptop in the building.
Instantly.
And Windows Home fundamentally lacks the software hooks to communicate with Active Directory. It cannot join the apartment complex. It can only ever be an independent house.
Exactly.
Okay, I understand why a home user doesn't need to join a corporate domain, but I'm going to push back hard on Microsoft's feature paywalls here. Microsoft deliberately locks full BitLocker drive encryption and remote desktop hosting behind the Windows Pro license. I find this completely indefensible, to be honest.
It's a common complaint for sure.
Right, because Apple encrypts iPhones and MacBooks by default for every single user. Why is Microsoft deciding that a home user with a laptop in a coffee shop doesn't deserve industry-standard drive encryption unless they pay an extra $100?
It is one of the most hotly debated topics in the IT community, and honestly, your frustration is entirely justified. To be precise, though, modern Windows Home devices do feature a stripped-down version called device encryption, assuming the hardware meets specific modern standby requirements. But it is not the fully manageable, robust BitLocker suite found in Pro.
Right, it's like a black box. You can't manage the keys. You can't encrypt removable USB drives with BitLocker to go. It's basically encryption light.
Yeah, and the justification Microsoft typically relies on is user error and data recovery. The PC ecosystem is vastly more open and hardware diverse than Apple's closed, vertically integrated ecosystem. Full BitLocker is a weapon of mass data destruction if it's mishandled.
How so?
Well, if a casual home user encrypts their main drive, loses the 48-digit recovery key, and then their motherboard fails, that data is cryptographically shredded forever. No data recovery service on Earth can get it back.
Ouch.
Microsoft historically viewed that level of permanent data loss as a massive support liability for consumers. In a corporate environment with Pro, Active Directory automatically backs up those recovery keys to a central server, which mitigates the risk entirely.
See, that still feels incredibly paternalistic to me. We're keeping you safe by hiding the sharp tools.
Yeah.
It just feels like an excuse to squeeze small businesses who are forced to buy Pro just to meet basic data compliance laws.
I don't disagree with you there.
And what about remote desktop? Why can a home machine be a client, but not a host?
That one is purely a security surface area issue. When you enable remote desktop hosting, you are opening a dedicated port 3389 on your machine, actively listening for incoming connections from the outside world.
Which sounds risky.
Very. If a home user turns that on and doesn't configure their network firewall correctly, their laptop becomes discoverable to every automated hacking bot scanning the internet for open RDP ports. It is a massive vulnerability. By restricting Home to only be a client, meaning you can reach out to connect to your Office PC, but no one can reach in to connect to yours, Microsoft forcefully shrinks the attack surface for non-technical users.
Okay, I can reluctantly accept the security argument for remote desktop. I get it. But let's look at a tool that is purely about Management Group Policy Editor, or gpedit.msc. This is exclusively a Pro feature. What is happening under the hood here?
Yeah, group policy is the absolute lifeblood of IT administration. Underneath the Windows interface is the registry, which is this massive, complex database of every single configuration, toggle, and setting in the operating system. Modifying the registry manually is dangerous and incredibly tedious.
You can break your whole system.
Oh, very easily. So Group Policy Editor is a powerful graphical interface that allows an admin to change thousands of these registry keys at once, safely.
Give me a real-world scenario.
Okay, imagine you manage an accounting firm with 50 laptops. You realize that USB flash drives are a massive security risk. An employee could just download client tax returns and walk out the door. If those 50 laptops were running Windows Home, you would have to physically walk over to each laptop.
Oh, one by one.
Open the registry editor, find the specific key that controls USB mass storage, change the binary value to disable it, and then just hope the user doesn't figure out how to change it back.
That's a completely unscalable nightmare.
Precisely. But because they are running Windows Pro and are joined to a domain, you don't touch the laptops. You sit at your central Active Directory server, you open the Group Policy Management console, you flip one setting to disable USB removable storage, and you link that policy to the accounting department.
And that's it.
That's it. The next time those 50 laptops ping the server, they download the new policy, the registry keys are silently rewritten in the background, the USB ports are dead, and the local users are completely locked out of reversing it.
Total centralized tyrannical control. I love it. Now, there's one more Pro feature that stands out in the materials, Hyper-V virtualization. Why does a small business or an IT student need a Type 1 hypervisor on their desktop?
Just to clarify, Hyper-V is hardware-level virtualization. It allows you to carve up your computer's physical resources, like the CPU cores, the RAM, the storage, and assign them to completely isolated virtual machines. You can run a full independent instance of Linux or an older version of Windows right in a window on your desktop.
But why not just use something free, like VirtualBox?
Because Hyper-V runs closer to the bare metal. It is deeply integrated into the Windows kernel, making it incredibly performant. For an IT student, it is a digital sandbox. You can build a virtual network of 3 servers on a single laptop, deliberately infect one with a virus to study how it spreads,
Just for fun.
and then instantly wipe the virtual machine away without a single byte of malicious code ever touching your physical host laptop. For small businesses, it's about server consolidation. Instead of buying a physical server for email, another for files, and another for the database, you buy one powerful piece of hardware, install Windows Server with Hyper-V, and run 3 virtual servers inside it. It saves massive amounts of money and electricity.
So Windows Pro is really the entry ticket for serious networking, security, and virtualization. But if Pro is just for the small office, what happens when that office is an ocean? Like, what happens when you have a multinational corporation with 50,000 employees spanning 3 continents? You can't just rely on standard group policy anymore. The architecture has to change fundamentally, which is where the enterprise environment takes over.
Exactly. Windows Enterprise is designed to operate on a scale that defies traditional management. You can't even buy this version in a store. It is exclusively available through volume licensing agreements, usually bundled with massive corporate subscriptions like Microsoft 365, E3, or E5.
And the specs list some heavy hitters that Enterprise gets over Pro. Things like App Blocker, Direct Access, and Advanced Threat Protection. Let's start with App Blocker. If Pro lets an admin disable USB ports, App Blocker sounds vastly more aggressive.
App Blocker is the ultimate realization of the zero trust philosophy. In a standard Pro environment, if an employee downloads a random piece of software from the internet, as long as they have local admin rights, they can install it. This is exactly how ransomware typically infiltrates a network.
Because standard antivirus only catches known bad files.
Right. Standard antivirus is basically a blacklist. It says you can run anything unless I recognize it as a virus. App Blocker flips that paradigm entirely. It is a whitelist. The IT department creates a cryptographic hash, like a unique digital fingerprint, of the exact applications that are required for business operations. Microsoft Office, the accounting software, the web browser, they use App Blocker to declare that only applications with these specific cryptographic fingerprints are allowed to execute on the process.
So I try to download, like, Spotify to listen to music while I work. What happens?
The Windows kernel compares the fingerprint of the Spotify executable against the App Blocker whitelist. It doesn't see a match, so it instantly denies execution. It doesn't matter if the file is perfectly safe, and it doesn't matter if it's a 0-day ransomware virus that no antivirus has ever seen before. If it is not explicitly on the list, the hardware refuses to process the instruction.
Man, it is an ironclad wall.
Wait.
Now, what about direct access? The specs mention this as a VPN replacement.
Traditional VPNs or virtual private networks, they're clunky. An employee goes to a hotel, connects to the Wi-Fi, launches a VPN client, types in a password, uses a multi-factor authentication app, and waits for a tunnel to be established to the corporate office.
And if the Wi-Fi drops for even a second?
The VPN disconnects and they have to start all over.
It's a huge friction point for remote workers.
Direct access eliminates the user from the equation entirely. It utilizes IPv6 and IPsec encryption to establish a secure bidirectional tunnel to the corporate network. The absolute microsecond, the laptop detects an internet connection. The user doesn't launch an app, they don't type a password. The tunnel is established at the machine level before the user even reaches the Windows login screen.
Oh, wow. So as far as the laptop is concerned, whether it's sitting in a Starbucks in London or hardwired into a desk in New York, it behaves exactly as if it is physically inside the corporate network.
Precisely. And this allows IT administrators to push security updates and group policy changes to remote laptops, even when the employee is asleep and the laptop is just sitting in standby mode connected to the hotel Wi-Fi.
That is a massive paradigm shift for managing remote fleets. The specs also mentioned Advanced Threat Protection, or ATP. How does that differ from the standard Windows Defender you get on a Home or Pro?
ATP is an endpoint detection and response system. Standard Defender is looking for localized threats on a single machine. ATP is a vast cloud-powered behavioral analytics engine. It isn't just looking for bad files, it's looking for bad behavior.
Give me an example of bad behavior.
So if an Excel spreadsheet suddenly launches PowerShell and attempts to modify a registry key related to the boot sequence, ATP recognizes that chain of events as an anomalous attack vector. It instantly isolates the machine from the network, suspends the processes, and alerts the Security Operations Center, providing a full forensic timeline of the attack. It is enterprise-grade incident response built natively right into the kernel.
Okay, so Enterprise is the ultra-secure vault. But there is one acronym in this section that genuinely surprised me, LTSC, the Long-Term Servicing Channel. The specs describe this as a version of Enterprise that prioritizes extreme stability over new features.
LTSC requires us to look at computing as industrial infrastructure. For a consumer, Windows is constantly evolving. Microsoft pushes major feature updates annually, tweaking the start menu, adding AI tools, integrating new apps.
Which, let's be honest, often breaks things. We've all experienced a Windows update that suddenly causes the Bluetooth driver to crash or the printer to stop responding.
Exactly. For a home user, a broken printer is an annoyance. But think about where else Windows operates. Windows runs the MRI machines in hospitals. It controls the robotic welding arms on automotive assembly lines. It runs air traffic control radar screens.
Oh man, you absolutely cannot have an MRI machine force a reboot in the middle of a brain scan because it urgently needs to install the new version of Microsoft Paint.
It would be catastrophic. So Microsoft offers LTSC. When you install Windows Enterprise LTSC on an industrial machine, you are entering a specific servicing contract. Microsoft strips out all the consumer bloatware, no Cortana, no Microsoft Store, no pre-installed games. And critically, they guarantee that they will not push a single feature update to that machine for up to 10 years.
10 years. So it's frozen in time.
It receives critical security patches, but the underlying code base remains absolutely static. You validate the MRI software once, ensure it works perfectly, and you know with absolute certainty that the operating system will not change out from under you for a decade.
That makes complete sense. Now, alongside Enterprise, there are specialized editions for education. Windows Education and Pro Education. The specs highlight something called assigned access, which is commonly known as kiosk mode.
Consider the logistical nightmare of standardized testing in a digital environment. You issue 100 laptops to high school students for a major exam. How do you prevent them from simply hitting Alt-Tab, opening a web browser, and Googling the answers, or, messaging a friend on Discord?
You can't have a proctor staring at 100 screens simultaneously.
So, you utilize kiosk mode via assigned access. You configure a specific user account for testing. The moment the student logs in, the operating system bypasses the standard desktop entirely. It immediately launches the testing application in an enforced full-screen mode. There is no taskbar. There is no start menu. The keyboard shortcuts for task switching or opening the task manager are intercepted and disabled at the hardware level. The $1,000 multi-purpose laptop is instantly transformed into a dumb terminal that can only execute one single application.
And it stays that way until the administrator issues the unlock command. That's crazy. It's also what they use for those digital check-in screens at airports, right?
Yes. Anytime you interact with a touchscreen in a public space, it is almost certainly a Windows or Linux machine locked down via kiosk mode to prevent public users from accessing the underlying file system.
So we've mapped the entire spectrum, from the sovereign home user up to the multinational hospital and the massive university system. We see how features are dictated by user needs and corporate security. But this brings us to a really fascinating pivot. Sometimes, the features in your operating system aren't dictated by Microsoft, and they aren't dictated by what you want. They are dictated by international law.
Yes. The legal exceptions. This is where the code compiled in Redmond, Washington, collides directly with regulators in Brussels.
We're talking about the N editions of Windows. The specs state that these versions are distributed exclusively in the European Union and the European Economic Area. And their defining characteristic. They have all the media features violently ripped out of them.
Yeah.
No Windows media player, no Groove Music, no voice recorder, no Skype. They were built specifically for antitrust compliance.
To understand why a government would force a tech company to make their product functionally worse out of the box, you have to look back at the defining tech legal battle of the 1990s, the browser wars.
The U.S. government versus Microsoft over Internet Explorer.
Exactly. Back in the 90s, Netscape Navigator was a massive, successful web browser. Microsoft recognized the internet was the future, so they built Internet Explorer and bundled it directly into Windows for free.
And because Windows had a 90+% monopoly on desktop operating systems at the time, Every single PC in the world suddenly had Internet Explorer as the default.
Right. Why would a consumer go out and purchase Netscape when there was a perfectly functional browser already sitting right on their desktop? Netscape was crushed. The U.S. Department of Justice sued Microsoft, arguing that they were illegally using their monopoly power in the operating system market to destroy competition in the adjacent browser market.
So how does this lead to media players in Europe?
Well, a decade later, the European Commission watched Microsoft doing the exact same thing with digital media. Real Player and QuickTime were struggling to compete because Microsoft was bundling Windows Media Player into the core of Windows. The EU leveled a massive antitrust fine against Microsoft and mandated that they must offer a version of Windows that unbundles the media playback framework, giving third-party software developers a fair chance to compete for the user's attention. That legal mandate birthed the N edition.
Okay, I understand the macroeconomic theory behind leveling the playing field. I do. But let's look at this from the perspective of an actual human being living in Germany who just bought a new laptop. Does this actually benefit the consumer? Because buying a computer, double-clicking an MP4 video file, and having the computer just throw an error code because it literally doesn't have the codecs to play video sounds like a horrific user experience.
This raises an important question about the friction between regulatory intent and user experience. Regulators view defaults as destiny. If a media player is there by default, the consumer won't seek out alternatives, which stifles innovation. The N edition forces a moment of friction. The user must actively choose which media software to install.
But the specs note that if a user buys an N edition, they can just go to the Microsoft website and manually download the media feature pack to restore all the missing Microsoft tools.
And realistically, that is what almost every consumer and IT department does immediately upon setting up an N edition machine. The regulatory intent was to foster competition, but the practical reality is that it often just creates a frustrating extra step for the end user who expects a modern computer to be able to play a video right out of the box.
It is a fascinating artifact of tech history, embedded right in the kernel. Now, there's another exception listed here that isn't about antitrust, but about radically shifting how a PC operates, and that is S mode. The specs describe it as a streamlined desktop style that only allows apps from the Microsoft Store, providing better security but limited flexibility.
S mode is Microsoft looking nervously at the success of Apple's mobile operating systems and attempting to replicate that exact security model on a desktop.
You mean the walled garden approach?
Precisely. Think about how an iPhone or an iPad functions. You cannot simply open a web browser, navigate to a random URL, download an executable file, and run it. The operating system explicitly forbids it. You can only install applications that have been submitted to Apple, reviewed for malicious code, cryptographically signed, and hosted on their official app store. Apple acts as the bouncer at the door of your device.
Which is why it is notoriously difficult to accidentally install a virus on an iPad. It's an incredibly secure model.
S mode brings that exact bouncer to Windows. If you buy a laptop running Windows in S mode, the traditional freedom of the PC is revoked. You cannot download Google Chrome from the web. You cannot download a custom game from an indie developer's website. If the application is not officially vetted and hosted in the Microsoft Store, the Windows kernel will absolutely refuse to execute it.
So I can see the massive appeal here for specific demographics. Like if you are buying a laptop for a 7-year-old for school or for an elderly relative who is prone to clicking on deceptive pop-up ads, SMUD is a godsend. You have absolute peace of mind that they cannot accidentally destroy the system by downloading a rogue executable.
It effectively neutralizes 99% of traditional malware and ransomware vectors.
But I'm going to push back on the broader implications of this. The fundamental promise of the personal computer, the ethos that birthed the entire Silicon Valley revolution, was that the machine belongs to the user. It is a general-purpose workshop. If I want to write my own code, compile it, and run it on my own silicon, I should be able to. S-mode treats the user like a child who can't be trusted with sharp objects.
That is the eternal tension in cybersecurity, isn't it? Freedom versus security. S-mode sacrifices ultimate flexibility for ultimate safety. And it's worth noting that Microsoft recognized this friction. If you buy an S-mode device, there is a one-way toggle. You can go into the settings and permanently switch out of S-mode into standard Windows Home or Pro.
But once you leave the walled garden, you can never go back in.
Correct. It is a one-way trip to the open internet.
Okay, so you've navigated the antitrust laws, you've debated with yourself over Home versus Pro, and you know what version you want. Now comes the bureaucratic nightmare: how do you legally acquire it, and what happens when your hardware eventually breaks? This brings us to the red tape, deciphering licensing types.
Software licensing. The invisible web of contracts that dictates what you actually own. Because, to be clear, you do not own Windows, you are merely licensing the right to use it under extremely specific conditions.
The specs break down three main consumer licensing models: OEM, retail, and digital. Let's start with OEM. Original equipment manufacturer. This is the license that comes pre-installed by companies like Dell, HP, or Lenovo. And the critical bolded detail here is that an OEM license is non-transferable. It lives and dies tied to the original motherboard.
This concept catches an alarming number of consumers completely off guard. When you walk into a big box store and buy a $500 laptop, the price of the Windows license is baked into that cost. But Microsoft did not sell Dell that license for the $139 retail price. They sold it in bulk for pennies on the dollar.
Volume discount.
Extreme volume discount. But the legal and technical stipulation of that massive discount is that the license is cryptographically married to the specific hardware signature of that exact motherboard. The license is not portable.
Let's use an analogy. An OEM license is like buying a custom-tailored suit. But the suit doesn't belong to you, it belongs to the mannequin you bought it on. The suit is stitched directly onto the mannequin's dimensions.
That is painfully accurate.
So, if a power surge hits my house, fries the motherboard of my pre-built PC, and I buy a replacement motherboard and swap it in, what happens when I turn it on?
The suit bursts at the seams. When the machine boots up, Windows calculates the hardware signature of the new motherboard, compares it to the license key stored in its activation files, realizes it is residing in a different body, and instantly deactivates itself. Your OEM license is legally and technically dead. You have to purchase a brand new copy of Windows.
Ouch. So the alternative is the retail license. You buy this separately, either physically in a box or directly from the Microsoft website for full price. And crucially, this license is fully transferable.
Following your analogy, a retail license is like a heavy winter coat. You buy it, you own it, and it belongs to you, not the mannequin. If you buy a new computer, you can take the coat off the old machine and put it on the new one, provided you only wear it on one machine at a time.
This dictates how you could build computers. If you are an enthusiast who builds custom PCs, and you know you're going to swap out the motherboard every 3 or 4 years for better performance, buying an OEM license online to save $50 is a trap. You will end up buying it over and over. You must buy the retail license because that one key will travel with you across multiple different physical computers for a decade.
Exactly. It requires strategic foresight about your hardware lifecycle. And this brings us to the modern evolution of tracking all this, the digital license.
The specs say the digital license links your activation directly to your Microsoft account. If it's linked to a retail license, you can seamlessly transfer it using the activation troubleshooter.
Digital licensing is Microsoft's desperately needed fix for a historically agonizing user experience. For decades, a Windows license was a 25-character alphanumeric product key printed on a tiny, fragile holographic sticker slapped on the side of a PC case.
Oh, I remember the absolute panic of building a PC, formatting the drive, and then crawling under a dusty desk with a flashlight, trying to read a smudged product key. Is that an 8 or a B? Is that a G or a 6? And if you couldn't read it, your operating system was held hostage.
It was barbaric. The digital license removes the physical sticker from the equation entirely. Microsoft now uses a process that generates a cryptographic hash of your hardware components and stores it in the cloud, linked securely to your email address. When you build a new PC, you don't type in 25 characters. You simply log in with your Microsoft account.
And what happens in the background?
The activation troubleshooter reaches out to Microsoft's activation servers, verifies that your account possesses a valid retail entitlement, registers the hash of your new hardware, deactivates the old hardware profile, and activates your new machine seamlessly. It transforms a painful bureaucratic hurdle into a simple login screen.
Okay, so you have your license, you own the right to the code. Now comes the moment of truth, flashing that code onto physical silicon.
Welcome to the final frontier, the upgrade path and installation mechanics. This is where theory becomes practice, and where one wrong click can absolutely nuke your precious data.
It is the most high-stakes interaction a standard user will ever have with their computer.
The specs outline two fundamentally different approaches to installing Windows the in-place upgrade versus the clean install. Let's define the stakes. An in-place upgrade installs the new operating system over the old one, but keeps all your personal files, your installed applications, and your settings exactly where they are. I like to describe an in-place upgrade as renovating a kitchen while you are still living in the house. You leave all your dishes in the cupboards, you leave the food in the fridge, and the contractors somehow swap out the floor and the cabinets around your stuff. It is incredibly convenient. When it works perfectly, you reboot, and everything is exactly as you left it, just running on a newer engine.
But the danger is registry rot, right? If your old kitchen had a mouse problem or weird plumbing leaks, the new kitchen might inherit them. If your Windows 10 registry was bloated with conflicting drivers and broken software remnants, an in-place upgrade to Windows 11 will just carry all that garbage over into the new OS.
Exactly. You are carrying forward the technical debt of your past usage. This is why IT professionals often advocate for the second method, the clean install.
A clean install formats the drive. It wipes everything. The specs state you use a clean install for malware removal, repurposing a system, or replacing an older OS.
To continue the analogy, a clean install is bulldozing the entire house, clearing the lot down to the dirt, and building a brand new, structurally perfect house from scratch. It is inherently destructive. Every file, every photo, every app that is not backed up elsewhere is vaporized.
Which is terrifying for a lot of people.
It is, but it is the only way to guarantee a pristine, flawlessly functioning operating system. If a machine has been compromised by a deeply embedded rootkit or severe malware, you cannot trust an in-place upgrade to remove it. The malware might just migrate to the new OS. You have to bulldoze the site and salt the earth. A clean install provides cryptographic certainty that the system is completely clean.
But before you can even lay the foundation for that new house, the specs introduce a deeply technical, low-level concept regarding how the physical hard drive itself is maxed out. You have to format the drive, and you are forced to choose between two partitioning schemes, MBR and GPT.
This is one of the most critical evolutions in storage technology, and it often operates entirely invisibly to the user until something breaks.
Let's decode it. MBR stands for Master Boot Record. The specs associate it with legacy BIOS systems. It has a strict maximum drive size of 2 terabytes, and it only allows for 4 primary partitions.
MBR is an ancient technology. It was introduced in 1983 with MS-DOS 2.0. Think about that time frame.
We were dealing with floppy disks and hard drives measured in megabytes.
Right. MBR dictates that the very first sector of the physical hard drive logical block address 0 or LBA0 contains the master boot record. This is a tiny 512-byte sector that contains the absolute most critical information on the drive. It holds the bootloader code that tells the computer how to start Windows, and the partition table, which is the map of where all your C drives and D drives physically reside on the spinning platters.
So the entire brain of the hard drive is crammed into 512 bytes at the very beginning. Why does it hit a wall at 2 terabytes?
It's another mathematics problem, very similar to the 32-bit RAM issue we discussed earlier. The MBR partition table uses 32-bit values to record the starting and ending sectors of a partition. If you take the maximum 32-bit number, about 4.29 billion, and multiply it by the standard sector size of 512 bytes, the math tops out at exactly 2.19 terabytes.
So it just runs out of numbers.
Literally runs out of numbers to map any physical storage space beyond that point. If you plug a modern 4-terabyte hard drive into an MBR system, the computer will only see 2 terabytes, and the remaining space will be invisible, unusable black space.
Which is a massive problem, because today a 4-terabyte drive costs less than $100. So MBR is mathematically dead for modern storage. That brings us to the replacement GPT, or the UED partition table. The specs say this is required for modern UEFI systems, can handle drives massively larger than 2 terabytes, allows up to 128 partitions, and stores multiple copies of the data for redundancy.
GPT represents a total architectural rewrite of how a computer interacts with storage. First, it uses 64-bit values for logical block addresses, which pushes the maximum drive size into the zettabytes, a number so large it effectively removes storage limits for the foreseeable future.
But the most important word in the GPT specs to me is redundancy. Redundancy is life in IT. You mentioned that MBR stores the partition table in one single 512-byte sector at the beginning of the drive. What happens if a power surge causes a microscratch on that exact physical sector?
Total catastrophic failure. The data on the rest of the drive might be perfectly fine, but the map is destroyed. The computer looks at the drive and says, I see raw magnetism, but I have absolutely no idea where the files are.
That is a terrifying single point of failure. How does GPT fix it?
GPT utilizes redundant structures and cryptographic checksums. It writes the primary partition header and the map at the beginning of the drive from LBA1 to LBA34. But then it writes an exact identical backup copy of the header and the map at the very end of the physical drive.
So there's a backup map.
Furthermore, it uses a CRC32 checksum, a mathematical algorithm, to constantly verify the integrity of the primary map. Every time the system boots, it runs the math. If a bad sector or a sudden power loss corrupts the primary map at the beginning of the drive, the math won't match.
Oh, wow.
The UEFI firmware instantly detects the corruption, silently retrieves the pristine backup map from the end of the drive, repairs the primary map, and boots the system.
The system detects a fatal error and surgically repairs its own brain before Windows even starts loading, and the user never even knows it happened. That is brilliant engineering.
It is vastly superior technology and is a mandatory prerequisite for the final and arguably most controversial topic in our deep dive, the Windows 11 hardware requirements.
Okay, here we go. The elephant in the room. The specs list an incredibly strict set of hardware gates required to install Windows 11. You need a GPT-formatted drive. You need a modern CPU, specifically an Intel 8th generation, an AMD Ryzen 2000 series, or newer. You need 4 gigs of RAM, 64 gigs of storage, and a DirectX 12 compatible GPU. But the real sticking point is this. You must have a motherboard with UEFI Secure Boot enabled and a physical TPM 2.0 microchip.
This list of requirements represents the most aggressive and unforgiving hardware cutoff in the entire history of Microsoft Windows.
Wait, I really need to unpack the scale of this. If I have a custom-built gaming PC from 2017, it has a 7th generation Intel i7 processor, 32 gigs of RAM, and a massive graphics card. It boots in 3 seconds and runs perfectly right now on Windows 10. Are you telling me that because it has a 7th gen chip instead of an 8th gen chip, I am literally forbidden from upgrading to Windows 11?
According to Microsoft's official supported upgrade paths, yes, you are completely blocked. The installer will halt and tell you your PC does not meet the minimum requirements.
And the specs clearly state that the lifecycle for Windows 10 support ends on October 14th, 2025. That means no more security patches. So millions of powerful, perfectly functional computers are going to become dangerously obsolete overnight. We're looking at a tidal wave of e-waste, millions of laptops hitting the landfill because of an arbitrary CPU cutoff.
Your concern about e-waste is entirely valid, and it has caused a massive uproar in the consumer and IT communities. However, I must clarify that from a cybersecurity perspective, the cutoff is not arbitrary. It represents a necessary, agonizing paradigm shift in how we secure computing devices against modern threats.
Okay, I am pushing back on this. Defend the necessity. What is so magically important about TPM 2.0 that it justifies bricking millions of computers?
Let's define the threat landscape. For decades, we relied on software like Norton or McAfee antivirus to stop malware. But malware evolved. Nation-state actors and ransomware syndicates developed rootkits and bootkits. These are incredibly sophisticated viruses that learn how to load themselves into the computer's memory before the operating system and the antivirus software even boot up.
Right. It's like a burglar hiding in the basement of the bank before the security guard even clocks in for the day. Once the guard is there, the burglar's already inside the system.
Precisely. If the virus is running underneath Windows, Windows cannot see it and therefore cannot stop it. The only way to defeat a bootkit is to move the security perimeter away from the software and down into the physical hardware. This is where TPM 2.0 and UEFI Secure Boot come in.
What exactly is a TPM chip?
TPM stands for Trusted Platform Module. It is a dedicated physical cryptographic microchip soldered directly onto the motherboard or integrated into the CPU itself. It acts as a secure vault for cryptographic keys and performs hardware-level math.
And how does that stop the burglar in the basement?
Through a process called the Secure Boot Handshake. When you press the power button on a Windows 11 machine, before Windows is even allowed to start, the UEFI firmware wakes up. It uses the TPM chip to examine the digital signature of the Windows bootloader files. It performs a cryptographic hash, measuring the code byte by byte, and stores those measurements in secure registers inside the TPM chip.
It's verifying the identity of the software.
It is mathematically proving that the boot code has not been tampered with since Microsoft digitally signed it. If a rootkit tries to inject malicious code into the boot sequence, the cryptographic hash will change. The TPM chip will instantly detect that the math no longer matches the expected signature. It will declare the boot sequence compromised, and the UEFI firmware will literally halt the boot process at the hardware level. The virus is trapped outside the gate, and the machine refuses to start the compromised OS.
It's a hardware-enforced chain of trust.
Yes. Microsoft looked at the escalating devastation of ransomware attacks paralyzing hospitals and pipelines and decided that the old model of software security was definitively broken. They realized they could no longer guarantee the integrity of Windows if it was running on legacy motherboards without these specific cryptographic coprocessors and virtualization features found in 8th gen and newer CPUs. The hardware cutoff is brutal, and it will cause massive e-waste, but the security gains against low-level malware are undeniable and necessary for the modern internet.
So it's a harsh medicine to cure a lethal disease. You either accept the hardware purge or you accept a world where ransomware runs rampant. Before we wrap this up, the specs mention one final thing about the mechanics of the upgrade itself edition mapping.
Yes, this dictates how licenses translate during the upgrade.
Upgrades happen laterally. If you are running Windows 10 Home, you will be upgraded to Windows 11 Home. If you are on Windows 10 Pro, you go to Windows 11 Pro. You cannot use a free generation upgrade to magically jump tiers and get a free Pro license.
Correct. You keep your place in the ecosystem, your license is upgraded in generation, but not in capability.
Wow. Okay. We have covered an immense amount of ground today. Let's do a quick recap of the journey. We started at the absolute physical foundation, diving into the mathematics of memory addressing to understand why a 32-bit system crashes into a 4-gigabyte wall, and marveling at the vast 16-exabyte expanse of 64-bit architecture. We climbed up to the software layer, comparing the independent sovereign island of Windows Home to the centrally managed, policy-driven corporate domain of Windows Pro.
We saw how enterprise takes that management to an industrial scale with cryptographic application whitelisting through app locker and machine-level tunnels via direct access.
We crossed international borders to dissect how the European antitrust lawsuits of the browser and media player wars literally changed the code of the operating system to create the enemy editions. We explored the security versus freedom debate of SMO's walled garden. We navigated the treacherous red tape of software licensing, learning why buying an OEM key locks your software to a single motherboard, while a retail license travels with you for life. And finally, we dug into the physical installation, learning the critical mathematical differences between MBR and GPT, and unpacking the brutal cryptography-driven hardware requirements of Windows 11.
It is a profoundly complex ecosystem. But as we established at the beginning, understanding this architecture isn't just for IT professionals. It empowers you to take control of the machines that run your life.
It really does. You aren't just guessing at pop-up windows anymore. You know how the engine works. But as we close out, I want to leave you, the listener, with a final provocative thought, something to really mull over that emerged vividly from connecting all these different specs together.
When you look at the entirety of this material, from App Locker to S-Mode, from TPM 2.0 to Secure Boot, a clear, unmistakable, and somewhat chilling trend emerges. Microsoft is systematically tightening the screws. They are using cryptographic validation to increasingly lock down the operating system at the physical hardware level.
Right. They're closing the open ecosystem.
And while this undeniably protects users from devastating cyber attacks and ransomware, it fundamentally redefines the relationship between the user and their machine. It restricts what you can do with the physical silicon you legally purchased. As operating systems become inextricably fused with hardware security chips, we have to ask a difficult question about the future of computing.
Are we approaching an era where the concept of a general-purpose PC, the Wild West, do-whatever-you-want open workshop that built the entire tech industry, goes completely extinct in the name of safety? Will the computer of the future be an appliance, locked down, tighter than a bank vault, rather than a canvas?
It is the defining architectural question of the next decade.
It's a heavy thought. But for now, practically speaking, I encourage you to take immediate action. The specs mention a tool called the Microsoft PC Health Check. Download it, run it today. See exactly where your own hardware stands in this diagnostic landscape. Find out if your machine has that TPM 2.0 chip enabled, or if you are on a collision course with that October 2025 deadline. Because unlike a medical diagnosis where you just have to accept what the X-ray says, in the digital world, once you understand the architecture, you have the power to change it. Thank you for taking this deep dive with us today. We'll see you next time.